When we're out in the field, we get approached a lot about how to use the Orion API to automate some of your work. And we've talked about it a number of times this year and provided samples on Thwack, but I figured it was time to give a primer. And people frequently ask me, why do I want to bother to learn this? Simply speaking, you would want to use the API because you don't want to do repeated process. Let's be serious, repetitive and boring tasks are repetitive and boring. They're also prone to error because there's so many human pieces involved. One of the things you can do better is think about the way you want to do this. My philosophy is, if you do something once, totally fine to do it by hand. If you do something twice, think about a way to script that out. And if you're doing something 3 times, then why aren't you already working with the script? A lot of our customers have done amazing things with the automation and extensibility with the Orion API, but a lot of people are also scared of it. So I want to really set a primer for how everyone can get started. These are going to be very simple examples you can follow along with using your existing systems and shouldn't do anything destructive, so you can play around either in your production environment or your lab. But I got a couple of recommendations. First and foremost, set yourself up a lab. It's really easy. Download the bits, install it in express mode, you'll be fine. The other one is I will install some software that I don't necessarily recommend you put on your Orion server. If this is your lab environment, that's 100% fine. However, if you're going to be working with this in a production environment, I think you should think of 1 of 2 different ways to handle this. The first way would be to use your own desktop or machine as basically a proxy for that, to run the scripts, to troubleshoot them and work on them. The other one would be to set up what I refer to as a utility server, which is basically adjacent to your Orion server. And the reason I call it adjacent is I want it on the same subnet so that they can talk to each other cleanly and easily. But by not putting this extra software on the Orion server, you keep it clean and you don't actually have negative benefits from having to reboot whenever you update things like this. The software I'm going to be using today is actually 4 pieces. It's going to be the SWCL Studio, PowerShell version 7 or later, Visual Studio Code, and the SolarWinds Orion PowerShell module. They're really easy to set up, and we will include documents on how to do that. So we're actually going to skip that part right now and dive right in. For all the examples we're using today, we're going to have to obviously authenticate with an Orion server. So this is the script I'm going to use to authenticate and do a quick test to make sure we're connected. If it doesn't connect, then it throws out an error. If it does connect, then it just lets you move on to the next stages. So what's going to happen in this script is we're going to put in a host name information. We're going to ask for some credentials, and then we're just going to build a test case. So if I run this, we're prompted for credentials and a password. Makes call out and says we're successfully connected. That's it. That's the entire part of the script. All it does is build a connection and then stores it so we can use it later in our other examples. Right now, all we are is connected to the Orion server. We're not actually working with any information on it yet. The best way to work with it is actually to explore it using SWCL Studio. You can just download that from GitHub. And I want to show you a couple quick things about learning how to navigate it. It's not very difficult. If you're familiar with other relational databases, it makes perfect sense. But there's some actors in there I want to call out. If you want to think about the heart of most SolarWinds monitoring systems, it's almost all based around the node, which is a single device that has children or related objects. If we take a router as a simple example, a router has interfaces and it has CPU, sometimes multiple CPUs, it has memory, occasionally it has storage, it has neighbors, it can have applications running on it. Same thing applies to servers. And the interesting part about that is it's really where everything kind of sprouts off of. So if we look within SWCL Studio, I'm going to go to the Orion nodes, which is here under the Orion namespace. So Orion and Orion nodes. You can see the pencil here, and that means this actually has full CRUD support. That's create, read, update, and delete, which means you can pretty much do anything you want to these types of entities. One of the main reasons that I use the SWCL Studio to do my browsing and understand what I'm working with is because it eliminates a lot of the need for joins. If you're familiar with traditional SQL, then that's how you connect 2 different entity types. You connect one table to another one through an inner, an outer, a left, or a right join. And it's fairly standard. We realize that not everyone's going to be a programmer, and that's one of the things we built into SWCL Studio and the Orion API is to be able to browse across these. The example I just gave was about nodes kind of being the center and the beating heart of monitoring. And if we go to nodes here, you can scroll down a little bit and see that there's also an interfaces navigation property. This gives you some interesting ways to get to information. In a traditional database, relational database, you would have to have a nodes query and an interfaces query and link them on some type of primary key. It's fine if you want to do it that way, but you don't have to using SWCL. If we start with something simple, just pulling out the ID, the IP address, and the caption of a node, and you want to get the interfaces, you don't have to go through a whole lot of connections, you just need to go and look for the interface's navigation property. So you can find it here with the little chain link icon. And if you want to access that, you can just type the name of that navigation property, and autocomplete is available. So now I'm pulling the node ID, the IP address, the caption, all of its interfaces, and the interface captions. This is a great way to avoid having to learn all about the data sets and where things join to other ones. That's why I always try to figure out where to start first with one of these calls. And today we're all going to be talking about the node. To start, we're going to unmanage a node. And for that, we're going to use a verb that's exposed through the Orion API. The reason you would want to unmanage devices is because you need to take them down for maintenance and you don't need the alerts on them. Now, there is a difference between unmanage and mute. We will get to mute in a second, but right now, unmanage will basically say stop collecting statistics and flag in a specific way. This can be done in the web UI, but if you go back to my original philosophy, if you're going to be doing this a lot and on a routine basis, find a way out to automate it. It's pretty simple. We'll just call the verb. The unmanaged verb takes 4 arguments. So the net object ID for the device I want to unmanage is N35. I want it to unmanage right now, and I want it to be unmanaged for 1 hour. So I can pull the date time, put that in the unmanaged time, and then just add an hour to that to have the remanaged time. And then the call is just invoke Swiss verb. And you pass that the connection, the entity on which you're doing the operation, the verb, and the arguments. Now, a lot of people are intimidated when they get started with this, but it's pretty simple. If you end up going over to SWCL Studio, you can actually get all of these arguments out of there and actually understand what parameters you need to send to each of the verbs. So let me show. Each one of the verbs has this breakdown about the data type that goes into it and the order in which the parameters need to be sent. If I wanted to unmanage this file server for an hour, all I need is the net object ID, 95, and then when I want it to start, when I want it to end, and I can send it across. I'll just build the parameters first. In this case, net object ID is a string, so it's n:95. The unmanaged time is right now. The remanaged time is right now plus an hour, and then its relative in this case is false. Then all I have to do is make the call, which uses the Swiss connection information I stored from my authentication script earlier. It needs the entity, which is essentially, in parlance, this table on which you operate, and then the verb, and then whatever arguments are required. So if I were to run this, no errors occurred, and then I can go back to this file server, and you can now see that that node is unmanaged. Now, unmanaging is slightly different than muting. Unmanaged actually just stops all polling. It says, until said time, we're just going to basically ignore this device. It doesn't exist for our purposes. Muting is a little bit different, and I actually like muting a little bit more, but it's not done as an action on a nodes table because muting can take place on multiple different types of devices. It's actually stored in a different entity in the API. But I wanted to give you an example of how to work with that. The reason I like muting better than unmanaging is because muting doesn't stop the polling. So I'll still get CPU, I'll still get memory information, I'll still get interface from the children and the volumes and so on and so forth. But what it does is basically puts a permanent pause on all the alert actions. So I don't get an alert for this. I don't fill up a log because something is down. But I still have those statistics, and I like this for maintenance windows. And especially if you have reoccurring maintenance windows, maybe you want to mute stuff in bulk, and it's not the simplest way to do in the web UI. It's not difficult, but especially if they don't have a common name or a common custom property, it can be a little tricky. So for me, I actually default to the API for this. And for that, we'll use the suppress alerts verb in the Orion alert suppression entity. In this example, we need to start off with a list of things we want to mute. And for me, I'm using a very simple example where I just want every single element that happens to be in the New York office, which in our case means the caption starts with NEWY. So there's a SWCL query for that. And that SWCL query says select the caption and the URI, that's the Uniform Resource Indicator, from the nodes where the caption starts with NEWY. It's fairly simple, but we have to start with that because one of the operators and one of the parameters you use for muting these kinds of things is the URI. The URI is just a unique element in the environment that uniquely identifies any single one thing in your monitored infrastructure. So when we make a call to it, it's not like the number 27, where you probably have an interface with ID 27 and a node with number 27 and a volume with 27. The URI is very specific and means when I have this URI string, it means that thing exclusively. So that's why we use it in a lot of these functions. So first we'll go through and pull everything that starts with NEWY, and we'll store that in a variable that we call to be muted. You can see the query here is very simple. Select the URI and caption from Orion nodes where the caption starts with NEWY. I also output some warning messages here just so we can all follow along and understand that when you run something like this, this is what's actually going to happen. Otherwise, you get very little return, and that's intentional. These are actually writing these warning messages because I'm showing you how to do this. In this case, it looks like we'll be muting 3 entities. That's NUI ADDC01, NUI Agent 02, and NUI ORCL 01. Perfect. They match our criteria. Let's go ahead and mute them. In this case, the arguments we're going to be sending are the entity URIs, and this is plural because this is an array. You can send a single one, but it's actually expecting an array to come in here. It's an array of strings. We're also going to have a suppress from, which is a date time, which can be null, which means it takes place instantaneously, and also a suppress to, which is another date time, which means it goes indefinitely. Most of these times I want them to start right now, similarly what we did with the manage and unmanage, and then suppress to. In this case, I just want it for 15 minutes. Maybe I'm just going through a reboot cycle in the New York office. I know it's going to be down. Just keep everything quiet for 15 minutes. So that's our scenario here. Now our to be muted content actually has a bunch of information in it. So if I actually look at that, to be muted, you can see we have the URI, and there's a couple of them, and the captions. What's nice about this is if I tell PowerShell that I just want the URI out of this, it knows that the URI is stored as a string, but it's basically multiple copies. So it automatically builds an array of strings. So to pull this out, all I have to do is say to be muted.uri, and it automatically builds my string array for me. Again, we will be going from right now, get date for suppress from, and 15 minutes. Then we make the call to Orion alert suppression as the entity, to the suppress alerts verb, and pass the arguments as necessary. You'll notice I actually wrapped the entity URIs in a pigtail or an @ symbol and then parentheses. And the reason I do this is this says anything within that is an array. And it's just one of the ways PowerShell defines arrays. And it's probably honestly the easiest way I've ever worked with it. So that way, if I actually do only have one entry here and it actually is a string, this says, technically we want to send an array of a single string instead. It's just an easy way to make sure you don't run into problems if you just happen to have one thing come through. And if we go ahead and run this, no error came back. So let's look at one of our New York elements. Perfect. This server has been muted, which means it will continue to poll. We will continue to pull information, but in about 14 and change minutes, it'll be flipped off of that, and we will actually start getting alerts again if it still has a problem. So some of the functions in the API, you can just make calls to verbs, but there's another way to do it if you need to update properties of something else. And the way we do that is with the set Swiss data PowerShell function. Now, this capability is available in all other programming languages. I prefer PowerShell, so that's what we'll be showing. I think it's a little easier for training purposes, so I want to show it to everybody for teaching. Now, for this one, you really only need 2 things. You need number 1, the URI. We already spoke about what that is, the unique identifying element. And the second thing you need is something that's either called a dictionary object, a hash table, or occasionally a property bag. I'll show you an example, but what you really want to understand for that is basically it is a group of data that says this thing equals this, and this thing equals this, and this thing equals this. So essentially you're really only sending 2 things, but the second thing you're sending has a whole bunch of data in it. It can have 1 element or it could have dozens of elements in it. It'll make more sense in the example, so let's dive in. The polling interval is just the time between calls out to a device, and it defaults to 120 seconds for most devices. And it just means every 120 seconds it's going to go out and say, hey, you okay? Cool? All right, we'll continue to report the status of up. But sometimes you have things that are pretty far away or things that are more critical and you need it closer. So I'm just going to show an example of how to update the polling cycle for a specific node, or in this case, any node that is over a specific response time. This is not necessarily a real world example. You probably have very specific scenarios in your environment, but it is a good working example to start off with. We're going to start with a query where we pull in the URI, the caption, the poll interval, and the current response time. And in this scenario, I just want everything that's already reporting is up, which in our environment is a status of 1, everything that has a response time of over 80 milliseconds, and everything that is not an ICMP node. And what that means is it's SNMP, agent, or WMI. Super simple. So first we need to do is get a list of all of those things. So this is our query. We're going to use the get Swiss data command to pull from our Swiss connection based on this query. So I can execute these. And now if I actually look at the contents of list of nodes, well, in this scenario, we only have one to change, but that's okay. This is something you can run on a routine basis. Again, salt this one to taste for your environment. But I still want to build this in such a way that it's repeatable. And for that, I want to use a for each loop. Now there's multiple ways to do these kind of iterations. You can use do whiles or while do loops or for I loops or for each loops. My default is for each, and it's not always the best for every scenario, but I like it because I get to use, in my mind at least, plain English syntax for these types of things. So in this scenario, for every node in my list of nodes, do this group of things. And for me, that makes more sense than necessarily for node element I of this number of things. This is not always the best. Like I said, if I want to show progress bars or something like that, I probably want to use the for I enumeration, but this one will work here. So we'll cycle through each node. And for our new interval, I want to take the current interval and I want to add 50%. It's not that crazy. So I'll take my current poll interval, which is at 120 milliseconds, and I want to take it up to 180. Again, I'm going to output a message because I just think it's important to let you know what you're doing. And then all I do is I use the set Swiss object, again with our connection, the URI of the element I'm working on, and then the properties. Now this is called, in PowerShell, this is typically called a hash table, and you can see it's really simple setup. I want to set the poll interval to my new interval. If I run this through, it says I'm updating NOC NFS 01V to 180-second polling interval. It's exactly what I want. Like I said, this is not necessarily the best way to do things for this particular scenario. I just wanted to give you an example. You could use this in real world places for maybe you have elements that are on the other side of the planet. Maybe you don't need intervals constantly. And that's why I use the response time as an example. All of my stuff is in a lab and relatively close, but you could probably come up with some type of calculation that says if something takes over 200 milliseconds to get back to me, then maybe I don't need to poll it every 2 minutes. Maybe I can let it poll every 5 minutes. The nice part about this, you could run this one example and do everything in mass instead of going into each individual element and saying, change the polling time. Go to the next element, change the polling time. Next element, change the polling time. So in the previous examples, we've used either invoke Swiss verb or set Swiss data, and that'll update this information for us. And that's the only thing you're going to need for every other example we're going to show from here on out. So we'll just jump right through these real fast. One of the scenarios I ran into at a previous engagement was where we had a bunch of floor switches where we wanted to monitor the ports, whether they were plugged in or unplugged, but we didn't want to monitor them and get an alert because they were user ports or phone-only ports. So I didn't necessarily need to know that they were down. I just needed to know that they were unplugged. Well, there's a status in Orion for that. You can just talk to the interfaces and say, hey, this interface is unpluggable. Now, it's easy to do this. You edit the interface, you check a box, you hit save. But what happens if you do this for dozens, hundreds, thousands of interfaces? Yeah, I wouldn't do that by hand. So what I'm going to do is show you an example here where on very specific devices that we've put in our query, specifically Cisco devices that have Ethernet, actual Ethernet connections, not fiber uplinks, not VLANs, and actually the caption starts with management, MGMT, I want to turn those into an unpluggable state. Pretty simple. Just like one of our previous examples, we're going to use the set Swiss object. We're going to send it to URI and then a hash table that we want to have updated. So here's our query. I'm not going to go through everything about it, but you can see the important part. Currently, the unpluggable flag is turned to false. The display name of the vendor is Cisco. It is of a traditional Ethernet, and the caption starts with management. Here's where we go and pull that list of interfaces. So I can execute these. And then I'll get the list of them. Just to double check. Okay, we've got 2 that would be flipped. As in our previous example, I'm going to use a for each loop. I'm going to send the URI, and then the property bag of unpluggable equals true. This is just a true false flag, super simple. I can run this. And there you go. I put a little warning message in there saying it's been updated. So let's double check and make sure it worked. So here's our Nexus 7000. We can look at the interfaces. Here's that management interface. If we edit that interface, you can see here it's been flipped to display as unplugged rather than down. Now, we only did this for a handful of interfaces, but in a large scenario where you have multiple endpoint switches and all of the ports are labeled as phone or user or printer or something like that, you could easily change this query to say, show me every single interface for every Cisco device that is of type Ethernet, that is a user port, and then flip them all to unpluggable. That way, when someone takes their laptop home or something, you don't get an alert because your alerts are set for down, not unplugged. Plus, they'll display differently in your interface, so you know, oh, this is just something that was unplugged. It's not actually a down problem. Next, I want to talk about some things that aren't necessarily node-based or interface-based or volume-based. I want to talk about alerts. Now, there are a lot of alerts that ship out of the box, and many of them should be turned off and salted to your taste for your environment. But sometimes you have a dev or a staging environment where you built an alert like, this is great, and you can build it somewhere else by hand, but wouldn't it be easier just to export and import it? And what happens if these actually start to diverge and you have lots of things over in your dev system? You're like, oh no, I need to get all of these in. You can export them one by one and then copy the files over, or you can make a call to that system, export them all to the file system, go to your target, import them all. It's not really difficult. Again, uses verbs. There's a verb for import and export on Orion alert configurations. Now, I do this a lot whenever I transition between systems, like I said, between a dev system or a staging system, but I also do it a lot whenever I want to back everything up just to have a safety net. It's not always necessary, but I've been burned in the past in any number of scenarios, so I like to have copies of everything, sometimes 2 or 3 times. So I'll do this a lot for my reports, I'll do it for my alerts, I'll do it for my modern dashboards. Alerts is one of the easier ones to understand, so I want to walk you through that. The export verb on Orion alert configurations requires 3 pieces of data: the alert ID, strip sensitive data, which is a Boolean, so a true false, and a password protection string, which is just a string. The second 2 are optional and not necessary, but I put them in there with blank values just because I like to be complete. In this case, we're going to find alert number 42. We are not going to strip the sensitive data because I'm moving it within my environment, and I'm going to use an empty string for the password because I don't need it. When we export this, it actually won't export to the file system, we'll export to a variable. So we need to capture that. So we'll run the verb against our Swiss connection on this entity, on the export verb, and we'll send it the alert ID, sensitive data, and the password protect. We'll just run this. All right, and if we look at alert content, and specifically we look at text inside of it, well, that's a whole bunch of information that's really annoying. This is not the ideal scenario. This is stored in raw XML, which is fine. You can dump this, but there's another way to do it in PowerShell. PowerShell has native knowledge of XML and how to work with it. So one of the things you can do is basically say this block of text is an XML file or XML content in this case, and then say, I have this and I want to save it. So we'll actually use what's called a method on a variable. So we'll take the inner text that we got back from this call. We will explicitly say this is XML content, and we'll store that in a variable called report definition. And then report definition has a method called save. And we will go ahead and save it with the name as an XML file in a subfolder we're just going to call Scratch. If I run these, and then I look at my Scratch folder, alert me when new traffic. There we go. That's the alert. So I've successfully exported out of Orion directly into the operating system. So then the question is, how do I do the reverse of that? Well, honestly, it's just the reverse of that. If you want to import an alert, the parameters are slightly different. The import verb requires 3 parameters, in this case, the alert XML, which is essentially just a long string of text. And the way you get that is you read the file from the file system and you just shove it right into that variable. It also requires the strip sensitive information and the password protection. Again, since I exported these from another system where I said these were blank and false, I'm going to use that again. And then I'm just going to go ahead and import it. And that is alert 151. And there it is. There's my alert. I know it is because I exported it from another system before, and it's already started triggering stuff. This is perfect. This is a great scenario of when you can work with something in a staging or dev environment. You say, yes, locked it in. This is good. This is what we want. You can take that and export it out. And then if you want, you can actually go into the XML file and flip the enabled flag to off, so you can import it without it being automatically enabled. In my scenario, this only goes to me as an alert, so it was fine. So like alerts, you can also do reports. Reports are also stored in an XML file, so you can just read the contents, pull out the definition, save it in an XML file, move it to somewhere else and import it. Super easy in the API. There are an import and export verbs available for those. But one of the newer features here is modern dashboards, and they're actually stored in a slightly different format. And it's actually one of the reasons I wanted to use PowerShell 7. Now, the PowerShell that ships on Windows traditionally is version 5 or 5.1, depending on the exact flavor of Windows you're running. And that's fine. But the newer versions have more intrinsic knowledge of certain languages, specifically in formatting languages like JSON. And that's why I really prefer to use it, and along with VS Code, because I get kind of a preview of what everything I'm working with. Now, there are import and export under Orion dashboards instances. You can just put the information in there, it'll dump out a file, copy it out of SWCL Studio, save it in a file, and then you can import it the same way using the other verb. But we like to do something a little bit better on that. In this case, I took that information and actually built a function for this, and this function is available on GitHub. You can just go to the SolarWinds Orion SDK GitHub, go into samples, PowerShell, functions, and it's called func, F-U-N-C _ modern dashboards. Once you have that, you can authenticate. Just execute this function to basically import the properties that it has and the additional methods it provides. And then we've actually written things that say export modern dashboard. You give it your Swiss connection, the dashboard ID, and where you want to put the file, and it automatically builds it out. Really simple. I'll show you step by step. I've already downloaded the function, so we can just keep our authentication, bring in this function. It's been loaded. And then to get more information on this, you can actually do get help for import modern dashboard and show me examples. And then in here, in the CLI, it'll actually give you information. So in this scenario, you can use and import a single one. You can import all of your dashboards. This is also assuming you've already taken these dashboards and put them somewhere else. But it just takes a JSON file. What it also does is it can take a folder. So if you actually dump all of these to one folder, it'll actually go through and import all of the matching JSONs in as modern dashboards. It will error out if it's a bad format, but that's to be expected. So let's go ahead and do one real fast. In this case, I have in my Scratch folder, import this other dashboard. I know it's not a clever name, but it does work. And it's a JSON file. So since we've already loaded the function, and we can just import this. And what's nice about this is it says, would you like to import it, and actually pulls the name out of it. So in this case, this is the SolarWinds status overview, and would you like to put it onto this particular Orion server? And I can say, yes, I do. Hit enter, and it's been done. So then if we go to that server, we go to our dashboards. So here's the SolarWinds status overview I just imported. And you can see it is incredibly big and complex. And this is what I really like about doing it for modern dashboards. The trick with modern dashboards is that they're not difficult to build. There's just so many different things you can configure in it. Configure colors, sizes, links, formats, whether it's a KPI or whether it's a pie chart or a donut chart. There's just so many things you can stick on one page that if you were to actually try to replicate this on another machine, it could take a really long time. Or you can just dump the file from one machine and import it onto another, and you're done. That's why I like using these PowerShell functions to do it for me. In fact, I like them so much, I'm just going to run this one. Pull in another one. Yes, I would like to import it. Oh, look at that. We already have a dashboard with that name. This is done intentionally so you don't copy over one you already have in there. Now, if I want to import or export these, same thing. In this case, we have this function we've built for you. You can just do export modern dashboard to the file system. What I like to be able to do, again, for backing up between systems, is you can give it an export modern dashboard and just say export everything to this particular folder, and it'll just dump all of them, including system ones if you send that parameter. So these are just a couple ways that you can work with the API to help streamline your workflow, because if you do something once, do it by hand. If you do it twice, think about a way to script it, and if you do it 3 times, you should already be scripting it. We've provided a couple examples here. We're going to provide other ones in the resources for the show. And always I'll be there on Thwack to answer any questions. So please jump to the Orion SDK forum, ask your questions there, and I look forward to seeing you online.